we're going to be starting some new stuff. It's not necessarily everything we do is going to have to do with area of rectangles, but a lot of it is. So keep in mind, the area of rectangles is a geometry thing. What we're going to be using it for is an algebra thing, and we're going to kind of be mixing the algebra and the geometry together, and you'll see what I mean by that later. But let's just stick to the geometry part of it right now. This doesn't have anything to do with rectangles, but it's just a general geometry question. What is area? So if I say find the area of a shape, of a triangle or a rectangle or a circle or anything, what am I asking you to find? What is the number, the answer, tell us about that shape? The area of an object tells us how much space it takes up, so how big it is in 2 dimensions. So Malik mentioned length. Length tells us how big something is in 1 dimension, so just how long it is. All right, but if we're talking about a rectangle actually has 2 dimensions. What do I mean by 2 dimensions? It has a length and a width, right? Or some people might say a base and a height, or height and depth, or you can use different names for the dimensions. But a rectangle has 2 dimensions. So if we just talk about the length of a rectangle, this rectangle might have a length given by this distance right here. But if we have another rectangle that looks like this rectangle has the same length as the other one, right? Are they the same rectangle? So if we're just talking about 1 dimension, the length of it might not be enough to say how big the rectangle is. All right, so as Aiden said, the area tells us how much space it takes up or how much space it covers. So if we were going to paint this thing, we would need more paint to paint this than we would need to paint this, right? You guys agree with that? Okay, so the area is going to be something that tells us how much space it covers or how much paint we would need or something like that. All right, so what you might want to write down in your notes here, let's clear these rectangles off. Area is just a number. So one thing to keep in mind is it's a number, and that's important. The bigger the number is, then what happens? If the number's really big, then what do we know about the object, the shape? What about the area? If the area is big, then we know that the shape is big, right? So if the number's big, then the shape is big. If the number's small, then the shape is small. All right, so the bigger the area is, or the bigger the number is, the bigger the shape is. So a number that represents how much space a shape covers. Now there's one more little thing I'm going to add to this, because we need to talk about how we get this number and what the number means. The number is actually going to have some units. If we talk about length, there's a big difference between 8 inches and 8 miles, right? Right? Okay, so we need units that go along with this, but since it's not a length, since we're talking about how much space it covers, what we're going to use squares. So if you look at like the ceiling up there has squares on it, right? So if we want to know how big this room is, if every room has the same size squares in it, we can tell which room is the biggest by seeing which room has the most squares covering the ceiling. Does that make sense? So we're going to measure area by using squares. So we're going to use things like square inches. How big is a square inch? It's a square that has what? It's a square, and each side of the square is 1 inch. Okay, so that's not a square. So here's a square. A square inch looks like this. It's 1 inch on this side, and it's 1 inch on this side. Okay, and actually all 4 sides are the same. But in a square or a rectangle, the opposite sides are the same. So I really only need to label this one, and that tells us this one's 1 inch also. All right, so a square inch, if we're measuring something in square inches, we're going to count how many of these squares would take to cover up that object. Okay, now, if we're talking about something a lot bigger than square inches, say the size of a town, we might use square miles. Okay, so instead of each side of the square being 1 inch, then each side of the square is, if we're talking about square miles, then we're talking about a square that is 1 mile on each side. That's a big difference from a square inch, right? So the units, when we're talking about area and geometry, the units are really important. Now that I've said that though, for algebraic purposes, for what we're going to do in this class, the units aren't really that important. We're not going to use units with these area problems. All right, so I'm not going to have you put that in the notes because it's not going to be that important for us. All right, so before we talk about the area of a rectangle, let's talk about what a rectangle is. What is a rectangle? Somebody describe a rectangle for me. So what we got out of all that, a rectangle is a four-sided shape We're not going to write this part down, but it's important that the sides are straight, right? So if I have a four-sided shape, but one of the sides looks like that, it's not a rectangle, right? I'm not going to put that in our description here, though. So it's a four-sided shape that what? What do I need in there? What do we know about the angles? With, yeah, what degree, Trevon? No, not 60, 90-degree angles. Or what do we call a 90-degree angle, Mark? What do we call a 90-degree angle?
A right angle.
A right angle. So we have a four-sided shape with four right angles. And actually that's enough to tell us that it's a rectangle. But we're going to add some to it because there's some properties here that are really important. So it has four right angles. A right angle is like the same angle as the corner of your paper, right? So you can check if an angle is a right angle just by holding your paper up to it. So it's a four-sided shape with four right angles. And what do we know about the opposite sides? They are congruent, yes. So the opposite sides are congruent. And I'm going to put underneath there so that we don't forget what that means. They have the same length. So finally what we want to know is, how do you find the area of a rectangle? We talked about what area means. We talked about what a rectangle is. So how do we find the area of a rectangle? And I want to start with this rectangle. But we're going to move over to this one to actually get a formula for it later. If I want to know how to find the area of this rectangle, remember we said to find the area we're trying to figure out what? Just read your answer from up above. What is area? What does it say, Trevon? We want to know a number that represents how much space this shape covers. All right? Now, one thing we talked about when we talked about area is how we measure area. What do we use? What shapes do we use to measure area? What did I say? We're going to measure it in, what were some of the units that I gave you? But we're going to measure this in squares. Okay, so it might be square inches, it might be square miles, square meters, square feet, one of those, but we're going to measure this with squares. So what I'm going to do is I'm going to break this rectangle up into squares just to show you how we're going to do this. All right, you can kind of see I did it already, but I'm going to make it a little easier to see. So if I want to know how many squares it's going to take to cover this, how many squares should I put along this side here? 2. Okay, we're going to break it up into 2 lengths because it has a measure of 2 units. So it doesn't matter if these are 2 inches or 2 feet or whatever. I want this broken up into 2 sections. How many sections do I want along this side? 3, because it has a measure of 3. Now it might be 3 inches or 3 feet or something like that, but it has a measure of 3. So I'm going to break it up into 3 sections, 3 equal sections. And so now what I've done is I've divided this rectangle up into what? I divided the rectangle up into, what kind of shapes are those? Yeah, so I divided the rectangle up into squares. Now, what's the difference between a rectangle and a square? Why are these now, these little shapes here, why are they squares? What makes them squares instead of just a regular rectangle? Aiden?
All the sides are equal.
All the sides are equal, exactly. So what we did here by doing that is we said this is going to be a length of 1 here, and this is going to be a length of 1 here, and those 2 1s are going to add up to our length of 2 along the side. And the same thing on the bottom. That's 1, that's 1, and that's 1, and so that's a total length of 3 along the bottom. All right, so each one of these shapes here inside of this rectangle is 1 unit by 1 unit. Okay, let's say 1 inch by 1 inch. Okay, so this is 1 square inch right here. How many square inches does it take to cover this shape? There's 6 squares there, right? So an easy way to find area for a shape like this is just count how many squares there are. There's 1, 2, 3, 4, 5, 6. Now how could we use some arithmetic, some math, to count the 6 squares rather than counting all the squares individually? Scott?
How many rows and how many are in each row?
Yeah, so how many rows there are and how many columns there are, right? So there's 2 rows and there's 3 columns going up and down. So if we, well, what can we use to figure out the 6? What do we do with the 2 and the 3? We can multiply them, right? So if we have 2 rows and we have 3 columns, then to count the total number of squares without having to count, then we can just do 2 times 3. So we would say the area of this rectangle, and you guys don't need to do this one, but we can say the area of this rectangle is 2 times 3, which is 6. For this rectangle, we don't really need to do that because it's really easy, right? But what if this was like 9 over here and this was, say, 11 over here? Would it be easy to split it up into 9 rectangles on this side and 11 rectangles on this side and then count them all? Can anybody tell me how many we would get if we counted them all? 99, right? How'd you get that, Aiden? Yeah, there's 11 nines. So there's 9 rows and 11 columns, so we multiply 9 times 11. So when the numbers get bigger, it makes it a lot easier to just multiply rather than count them all. Aiden didn't draw a picture and count 99 rectangles in that short time, right? He just multiplied. Now, what gets tricky is when we start throwing some variables in there. This h could be any number, right? And this b could be any number. You guys know what the b and the h stand for? What does the b stand for? Base, and the h stands for height. Okay, so the b could be any number. It could be 3, like it was in this problem, or it could be 7, or it could be 12.4. It could be really any number we want. And the h could be any number. So I can't count squares here. I can't say I'm going to divide this up into b squares on this side and h squares on this side because I don't know how many places I need to divide it into. So how do I find the area of a rectangle like this? So the area is going to equal what? 3 times 2. We can't count, so it's not going to be 3 and 2 here, but it's going to be what? What letters do I have here? What variables do I have? Yeah, it's going to be the base times the height, so b times h. So the area of a rectangle when we don't know the length and the width or the base and the height, we're going to say is just the base times the height. Or if we called them different variables, say we called this the width here and the length here, then we could say that the area is length times width, right? Okay, so we might use different variables at different times, but it's the same idea. We're going to do the length on one side times the width on another side. Or the base on one side times the height on the other side. All right, so the area formula is going to just be, and this is what you need to write down, for this particular rectangle, since we have the base and the height on there, we're going to say the area equals base times height. Now I do also want you to write this down because you're going to see it like this a lot too. This is exactly what I had written down before. It's also length times width. And length times width is just another way of saying base times height. All right, so where it says that the area formula, I want you to write those 2 formulas down, those 2 equations. Notice that on both of them I started with this big A here. What do you think the big A stands for? Area, right? So whenever we're finding an area, we're going to write down A equals so that we know that we're finding an area. We're going to use a capital A because that's what we use for area. Okay, so let's do a few examples. First example is really easy. I don't want to do this by dividing this side 8 ways and dividing this side 9 ways and counting the number of squares. That's going to take a long time. So how do I find the area of this thing? So again, when we're finding an area, we're always going to write A equals. So we have the area equals, and then we're going to do base times height. Does it matter if I do 8 times 9 or 9 times 8? Does it matter which order I do it? It does not. So I'm going to do 9 times 8, which is the same thing as 8 times 9. And what do we get when we do 9 times 8? So we have 9 times 8, which is what, Scott?
72.
72. Now, if we had, say, 8 inches on this side and 9 inches on this side, then my answer here would be 72 what? It wouldn't be inches, it would be square inches. So if our units were inches, then our units for our area would be squares, so it would be square inches. And the way we write that is inches to the second power, because that second power exponent would be squared. Like I said earlier, though, we're not going to be doing that for our problems, because our problems that we're going to be dealing with, this triad, are going to look more like this one, where it has a variable in there. And that's how the algebra is going to come into play. All right, so what's the difference between this problem and the last problem? Scott? Yeah, so the base this time is a variable. We don't know how long this side is. Does that mean we can't find the area? No, we can still use that area formula, right? But our answer is actually going to be a variable. We don't know exactly what the area is going to be because it depends on how big this is. Okay, the area of this rectangle would be different if this x was 6 than if the x was, say, 10 or some other number. And we don't know what number goes in there. So we can find the area, but we're not going to get an answer that's just a number. It's actually going to be an algebraic expression. All right, so how do we find the area of this thing? We're still going to do base times height here. So the base is x and the height is 8. So it's going to be 8 times x. And what is 8 times x? How do we write that? Actually, here, let me do this. I'm going to do the base first. So the base is x, the height is 8. So what is x times 8? What's the proper way to write that? Should I write x8 or 8x? 8x, right? So again, like I said earlier, the area of this one is not a number, but it's an algebraic expression. And we can put any number we want in for x. And so if the base turns out to be 6, then I could put a 6 in for x, and it would be 8 times 6, which would be 48, right? So I can put any number I want in for x in the picture here, and I put the same number in here, and that gives me the area. This is my final answer. That's the area of that rectangle. All right, here's another one kind of like that, except there's a variable on both sides of the rectangle this time. So Scott, what are we going to do here? Nope. This isn't 4 and this isn't 3. It's 3x and 4x, right? So Malik, what are we going to multiply together?
4.
Exactly. So the base is 4x times the height, which is 3x. Now this is taking us back a little bit, but let's see if we can remember how to do this. When we're multiplying numbers together, or expressions together like this, we're going to multiply the coefficients together first. What are the coefficients here? 4 and 3. What's 4 times 3? 12. Okay, so the 4 times 3 gives us 12, but we also need to multiply the x times the x. What is x times x? X times x is not 1x or x, but it's what? Aiden? X squared, exactly. X times x is x squared, just like 4 times 4 is 4 squared, right? So anytime we multiply anything by itself, we square it. So 4x times 3x is 12x squared. Anytime you multiply a variable times itself, we're going to, well, we have 2 of them, so we have to square it. So we get 12x squared here. Does that make sense?